Okay, so Megan knows that x equals y plus 5. She also knows that the sum of x and y is equal to the product of x and y. Using an algebraic method, show that x and y are not whole numbers. Now in this case here, right, we're given two things that she knows. She knows this here, right, which actually would produce a straight line, wouldn't it? Because it's of the form sort of y equals mx plus c, or we can get in that form, right, if we move things around. But let's look at this here. She also knows the sum of x and y. So x add y. That means, yeah, the sum of x and y. X add y is equal, so we've got equal there, to the product of x and y. The product means that, doesn't it? The product means x times y. So it says then, using an algebraic method, show that x and y are not whole numbers. Now, we've got one equation now that she knows. The sum of them is equal to the product of them. Okay, sum of x and y is equal to the product of x and y. But she also knows this as well. You might want to rewrite that and write it as y equals x minus 5, yeah? So if she takes that 5 over to the side, it becomes a minus 5. Alright, so we've got it then like y equals mx plus c. In this case now, if these two equations are related, the y's are going to be the same, the x's are going to be the same, so we can think about like simultaneous equations, right? Okay, like we did with the point of intersection, something like that. The trouble here is though, we can't get it to be y equals on both of them. This one I can say y equals x minus 5. Here I can't though, I can't say y equals something because I've got another y here, alright? It's not a problem, because what we can do is, if we think of these as two equations, right, 1 and 2, I can think of using 2, right, and substituting it into equation 1, okay? And this is what I'll do, right? So I'll literally write this down. I say, look, substitute, or sub, 2 into 1, right? The reason I'm going to do this is because from number 2, I know y is equal to x minus 5. I know that's the case. So if I substitute it into number 1 I've got x, right, which I'll write down. Then I've got y, but remember, y is just x minus 5 from number 2. So I'm going to substitute it in. So instead of writing y now, I'm going to write x minus 5. Equals 2. Well, I've got x there, so I'll write that. But remember now, again, y, I know y from number 2 is just x minus 5. So I can replace y with x minus 5. So I'll put in a bracket, okay, because there's two terms all of a sudden. But that's what y is, isn't it? Y is this. So I'm replacing y there, and I've replaced y here. And what we do then is we tidy this up a little bit. So I've got 2x there, yeah? Minus 5. And we can expand that bracket. So we've got x squared minus 5x. And then I'm going to get everything onto one side. So you've noticed then maybe we're going to get a quadratic. It obviously is forming into a quadratic here. So if I keep the x squared as positive, keep it there, and I'll take all this stuff over the other side. So 2x becomes minus 2x. And the minus 5, when I take it over, becomes a plus 5. And I'm left with 0. So simplifying this, I'll have x squared. That becomes minus 7x plus 5. And that equals to 0. Now, here we then think about factorizing it, right? But they want us to show that x and y are not whole numbers. So if they're not whole numbers, we shouldn't really necessarily be able to factorize it. Okay, we might be able to, but probably we won't be able to because they're not going to be whole numbers. Okay, let's see. Can we find two numbers that multiply to give 5 and add up to give minus 7? And if you think about it, we can't, because the only two numbers that multiply to give 5 are 1 and 5, and 1 and 5 you can't get 7 from that, right? Or minus 7. So what we're going to do, right, we're going to expect then these to be not whole numbers. We can expect them to be maybe irrational numbers, decimals, right? Okay. And we're going to use the formula method. All right, that's how we're going to do it. So if you remember the formula method, a would equal the number in front of the x squared, b is equal to the number in front of the x, and c is equal to the constant at the end. And then you're going to need to remember this, right, in the test, right? So x equals, okay, minus b plus or minus square root b squared minus 4ac all over 2a. Okay, so you substitute in your numbers. So b is minus 7, so you put it in there. Now, because you've already got a minus, don't forget that. Okay, so you end up having two minuses, won't you? B then is minus 7, so you've got to square it. So it'll be minus 7 squared. Take away 4 times a times c. And that will all be over 2a, which is just 2 times 1, yeah? If I simplify that, this becomes, well, 2 minuses make a plus. Work out that root. So what I do is, I literally type that in my calculator. I do minus 7 squared minus 4 times 1. I don't put the root on my calculator just yet. Okay, so I literally, that's what I'm typing into my calculator. Okay, so I get 29 in that root over 2. Okay, so then we see that x will equal, okay, so I'll write it up here, 7 plus root 29 over 2. Which comes out to be 6.19, or x will equal 7 minus root 29 over 2. Okay, so we get 0.81 if I round that, right? Now, of course, we can work out then what y is equal to based on these x values, right? You know, if we just sub it in there, yeah? So that means then y would equal 6.19 take away 5, which equals to 1.19, or y would equal 0.81 take away 5, right? Which would be, oh, my brain's gone this morning, which would be 0. In a sec, which would be minus, of course, 4.19. Okay, so you can see here that x and y are not going to be whole numbers. Okay, so we've actually proved it there.